How about that? Aha. Figured it out. I had the audio on my laptop. I didn't have the mic on, but the audio from the Zoom came through.
Yeah. Makes sense.
Crazy stuff. So my talk is a little different from the really deep technical talks of the other one. Mine is showing how to use, I figured it out, I think. Oh, we'll see if it actually comes through, but
It looks like it's good. Yes.
it looks like it's going through the Zoom and showing up.
Yeah, I see recording up in the corner, which means you're in Zoom.
Okay, so that's probably good.
Yeah.
It probably hears me. We're probably in a good place. We'll hope for the best. If not, okay, we'll find out later.
But tell us everything as a service.
Everything is a service. Yeah, pretty much. As long as you got the cloud and some money. Yeah. I don't even remember where that goes. Probably don't click that. No, I think that just goes to my blog or something.
Okay.
I run the meetup in Princeton. Cover all kind of data topics. We've been doing hybrid because a lot of people just don't show up anymore.
Yep.
Which kind of stinks. 2018, 17, get 100 people easy.
Yeah.
Now you get 10 people show up at a place. It's different in Europe though. It's still do 100-person meetup in Europe.
Wow.
Yeah. No
Zero
problem.
clicks to send the email to the individual. When they receive it, it'll actually trigger automatically.
Interesting. But I'll go through some of the things I think are a little more interesting. Is some technology people haven't seen before. If anyone wants a discounted thing and you're some reason going to Atlanta, get a discount for a conference in Atlanta. The guy asked me to put that. So what is streaming? This is kind of a loaded gun. I'm glad there's not more people in here because, you get some engineers in here and, all the way over here, the real time, they'll complain that that's not even real time enough. But when people are thinking, I have a phone, I send something, I get some data comes into my phone because I got it from Facebook or some app. This is where I'm thinking, and that is the sub-second range, where we try to get data as soon as it happens from an app, from any kind of system, sensors that isn't, nuclear system where it's instant. If I get a few hundred records a second, a few thousand, people are happy. That's generally the range we work with. A lot of different things can be done now in the open source, where before that just wasn't possible. Open source didn't have all the really cool tools out there. They were hidden in proprietary things that cost millions of dollars just to get access, like Oracle and IBM. But now they're all available, so you could just spin them up on your laptop and start using the same things that Netflix and Google and Amazon are using, which is pretty cool. Yeah. So the barrier to entry to start now is very low. If you have some kind of computer, even like a really good Raspberry Pi, not that you can find them anymore, you could run real streaming system pretty easily. And they all have cool logos. My favorite one, the squirrel from Germany, this is Flink. That one is a really nice logo. That one's pretty cool. But people spend a lot of time on their logos. Kind of important because all the swag have a good logo. But what's nice about these systems is you can do a very little coding. Less code you write, the less you got to worry about. But yeah, even these new systems like Apache NiFi is 12 years old. You have something running for 12 years. Obviously, you have legacy code and other things you already have to worry about. Because they try to iterate things very quickly in the internet, especially in open source. You have, what we call a flow you wrote, 5 years ago. And people are like, oh, why do you have all that old junk there? You do all weird stuff. And try to get people to move stuff, even if it's drastically better, really hard, even if it's simple. I mean, that's a universal problem. Hasn't gotten any better even in the last 10 years. There's probably no way to make that better. As long as it keeps running, does cool stuff. What's nice with these new systems is separation of what things do. So you don't have to try to do everything in some big, giant monolithic one system. Things can be broken up. People can have different things they're good at, which is nice. You don't have to be an expert at every part of a massive system that may span, different clouds, different networks, different computers, different programming languages. We start off, get some stuff from a device or from a system, get it into a stream so people can start using it. We can distribute it to different groups. This is with Apache Kafka. It's a really nice way to be able to send messages to people working with different systems. Again, a great way to share data between different languages. You may not have, people all on the same thing. Not everyone's using Java or Rust or Python. Lots of different systems out there. As long as someone has the ability to use Kafka clients, they're good. Once you get down the end, you want to do something fun with this data, not just ship it around. When you get to a place where people want to do something with it, get some kind of knowledge and insights out of it, there's a bunch of tools like Flink, NiFi, Spark, as well as people writing stuff by hand. But this lets you do common analytics and common applications pretty easily. When I show you the diagrams, you'll see how easy it is. The most complex something is maybe you have to know a little SQL. So it makes it a lot easier to get people who aren't, heavy duty programmers to be useful, which is nice. But obviously if things break down the bottom, that bubbles up to a place where people have no way to help themselves. Because obviously they don't understand how to debug networks or any of these things that are below your current high level. There's a new project came out of Yahoo a number of years ago, became open source. It's Apache Pulsar. What's cool about this project is it kind of helps you pull up some of the legacy systems without having to rewrite them, which I think might be of interest based on the last talk. So what Pulsar does is it acts the same way as Kafka to distribute messages. It's like a universal message hub, but it doesn't force you to rewrite to use one protocol. It supports, I don't want to say older, 20, 25-year-old protocols like JMS, RabbitMQ, MQTT, and for the base level down to REST and WebSockets. So you can take and RocketMQ is a Chinese messaging system. So you can use those natively as your protocol and have it transfer messages over between different protocols without rewriting the clients. Don't have to you could even not even change domain names, just change that in your router to where it's going. Pulsar will accept it natively, put it in its native system, get it modern distributed storage, be able to take your data, uplift it into different clouds, share it with new apps. No one has to rewrite the old thing that they may not understand. It just comes in and people send their messages to their old protocols that they used before. Nothing changes, moves into a new system, and now that data that has been in flight for 20 years and people used it only with Rabbit or only with MQTT are now in our modern Kafka stream. and being able to be used by the latest real-time streaming tools. Makes a nice way to be able to share data from different on-premise data warehouses, data locations with, different clouds without having to rewrite anything. And it happens at speed, and you can still have those same systems read it using the same protocol, but you can write a new app with a newer protocol, and they can interchange data between them. So obviously this doesn't go so far back as when we start getting Exodic and different non recent, recent like 30-year-old data formats, they tend to be, at least ASCII and maybe UTF-8, but there are systems that add another layer to translate Exodic and some of the mainframe things. IBM has fortunately added MQTT and JMS support to almost every mainframe in AS400. So there's a way to get there, and they support some levels of Kafka through Red Hat. So there's a way to get the data and not have to rewrite things, which is nice. And universal way to get data in. What's cool is not everybody wants to read data the same way. So you can subscribe to it any way you want, and gives you that flexibility. If you have to look at things as if it was, the work queue, you can do that. If you want modern streaming, you can do that. You don't really have to change anything. What's nice is whatever your message is, you don't have to change it. Keep it binary, keep it in some proprietary format if you wish. If it's in a more modern format like JSON, Avro, or Protobuf, that's fine as well. That makes things a little easier. But we keep your value, just your data payload, and we transmit that around. But we add some metadata around it. So if you need to add annotation, you don't have to mess with someone's binary data, which could be encrypted or could have some things on it that'll check sums that may not want you playing with it. So you can add different properties, value map there that go along with your message. And that way you could add annotations to say, hey, this came from, truck 7 in this legacy app running this version of a protocol. Don't have to worry about that. That doesn't affect the payload. Key to make sure I know where things are, try to keep it unique. Helps us for performance, for partitioning. Also useful for a number of other things, especially for auditing and trying to find your data when something goes wrong. Someone's broken network pipe somewhere. Lots of fun. Well, we make you tell us who you are when you put this data on there. Obviously, there's no one enforcing what's the name you put in there. If you put nothing in, we'll generate a horrible name of no value. But at least we have an idea who you could have been if you were nice. And we put an ID on there so we know things in order, because sometimes people want your data in order. Sometimes you want data to come through exactly once. Lots of things that happen when you're doing real-time data. I'll go through a couple of the side things. What's nice is for Pulsar is they support even just using the native protocol in a lot of different languages. So this isn't even talking about support for those other protocols which have their own language libraries. Support for Java, Python, Go, Node, Rust, C++, C#, Scala, WebSockets, REST, and there's a couple other experimental ones. Someone's working on Carbon, but if you can't get through with one of those, if you can't use REST or WebSockets, you probably got a pretty weird language. So maybe you shouldn't be trying to do streaming programming. And what's nice is support for all the standard open source stuff out there. So once you get your data into the open source ecosystem, you use pretty much any tool that's out there. That makes it a lot easier. You pulled yourself out of whatever legacy difficulties, and now everybody can use it. This has come in handy for a couple of government agencies. I had one that has been running the same system since the fifties. And the only people who even have an idea of it weren't the original developers. They were like second or third tier. They've rewritten it 3 times, but haven't been brave enough to put it into production. They let 3 systems run in parallel, and then someday they'll do a cutoff until they get a point where those 2 other systems are now legacy, that they rewrote these backups so long ago. The last one was like an early version of Java.
Yeah.
And they're not, it's because of some government requirements, they're too afraid to move it over.
Yeah.
So they're
It's
working
okay.
on the 4th one.
The original version was probably an RPG.
It's, yeah, it's, the guy I spoke to, we had a meeting with him in Virginia, and it was, he was just about to retire, and he's like, yeah, I saw the guys for a couple of weeks crossover, and that's as much. We don't have any idea how this stuff works. It still works. And which is impressive how long, and this is, I can't say what government agency, but all of our data is in there.
Yeah. Well,
And it's tied to a lot of money, so they won't change that. I'm hoping at some point when those systems no longer the hardware can run, someone will pick one of the slightly newer versions before we lose the people who do the first backup system, which was scary. We're like, oh, we'll have you rewrite it in this. We can do that whole system, and it'll take us with I guess legacy big data tools now. Like, it'll take you a couple of months, run faster, all these things that'll give you. They're like, yeah, we'll give it a try, but I don't know. Maybe in 20 years we'll put that one in, or it'll just sit on the shelf next to the other 3 versions of that, which is scary. So Kafka is a competitor to Pulsar. They're both open source. They're both run by the Apache Software Foundation. Kafka's been around a little longer. LinkedIn built Kafka because they needed a way to move messages around, but they had very specific needs. They wanted their messages in order, because really this started off as a way to take logs from all their different machines and they get them into one place. They could send them somewhere for looking at them. A lot of other use cases since then, but that was the whole point. There's a lot of companies and a lot of things based around them doing it. The implementation of Kafka, when it started, was pretty simple. It stores everything in just a big log file, a binary log file, and just pointers its way through it. Pretty simple, but effective. I forgot why they called it Kafka, but when I was in Prague, I'm wearing my Kafka shirt at the Kafka museum because it's, and only I thought that was. Yeah, so Kafka now is used at almost every modern website of size, whether it's Facebook or Amazon, Google. The only ones who aren't, the Chinese have switched to Pulsar. Because I don't know if they don't like, now that LinkedIn built by Microsoft, something there, I don't know. Pulsar also supports those different protocols, which is helpful, but these are really common use cases. Again, still logs and monitoring stuff, but getting data around, like how do you get data once it gets pushed from all these phones into some kind of central place so someone can see it on a dashboard. So some high level executive can go, oh yeah, let's get that all happen in a reasonable time. You know, if the internet's slow for 2 minutes, people are throwing their phone against the wall. So we got to get those messages around really fast. Pretty straightforward ideas how it works. The channel for passing data is the topic. I mean, what are you going to call it? Someone produces data, someone consumes it. They call their service brokers. They're brokering the data, and now they the new way of doing it. Everything goes into a broker. They've even added their own RAP protocol. They're trying to do a lot, see how well that goes. They started off small, simple, distributed. Now they've made their version 3.4 after 12 years. And a little, the code now is really hard to read. I mean,
You have to
Open source,
satisfy a lot of
yeah.
old,
Open source project that, you know, hundreds of people from different companies around the world have been working on. And, you know, they decide to replace things that have worked for a number of years with a new protocol. They got rid of, the way they did metadata with an external system that worked. Now they put everything into one. We'll see how that goes. I don't know. I'm a little worried with that. But the older versions work really well. And they help feed some things like Flink, cool logo. What's nice with Flink, if you follow the basic pattern and use the regular installs, you can have Kafka and Flink and other things installed without much overhead, maintain themselves, as long as you have disk space. And you can hand it to someone, they can write SQL and just write SQL against live data that's streaming in from different systems with not a lot of overhead, without the most complex distributed systems engineers in the world writing your code for you. And this seems to be working right now. I've got some customers who jump from legacy maintenance systems to running real-time systems with only one or two people I consider experienced coder. A lot of kids out of college, they just have to write some SQL, write a couple WYSIWYG things, and data's just flowing. It's very forgiving. It does a lot of the heavy lifting for people. As long as at least they understand basic SQL, it's pretty good. That doesn't mean that you can't break SQL, because there is a little weird stuff when you start handling things that aren't tables, since these are virtual tables on top of data that's streaming continuously. You know, things like looking at windows of data over time intervals comes into play, because you might not want to just look at the event that just came in, but you want to look at last couple minutes. The credit card people are huge on these. All the credit card companies have switched over to using Flink on Kafka for monitoring all credit card transactions. That's all the top four. I don't know about anyone beyond those four, but the top four are all using that same tech because it's fast and it's easy enough that I don't need a PhD to be able to understand the distributed processing, and this can scale out. What's nice with Kafka and Flink, they scale linearly, keep adding more nodes. Things have to shrink down now with Kubernetes in the cloud, pretty easy to spin up and down. They are smart decommissioning, so they'll distribute the data back, stop new ones from coming in. You don't have to worry about restarting things, rerunning data. Don't have to worry about data loss. Kafka is basically a built-in distributed global cache. And I've had people who will distribute that cache among all the AWS cloud regions in the world. The data gets distributed across the three US ones, over to the Pacific, through Africa, Middle East, through Europe, and keep them in sync pretty easily. Because someone has written that code for you. You don't have to do the heavy lifting, other than make sure you get, you know, premium support, and no one's forgotten when they set up their cloud to have some security in there, so they're networking. If someone's doing the hard stuff, maybe a vendor, maybe someone else. My favorite project, and has the most interesting backstory. Apache NiFi was originally called Niagara Files. This came out of the NSA. This was their first piece of software they open sourced. And when they did it, the team that wrote it left and formed a company. And 4 months later, their company got acquired. Because this is a really interesting project with a different style of working. It is not a messaging queue, not a development environment, it's not an ETL tool, but it kind of does everything. And they needed this because They wanted to be able to monitor live things like missiles or random stuff, just computers, stuff in your house. I mean, it's the NSA, they're watching everything. So this can connect to almost everything. And if there isn't a connector, you can write it in Java, deploy it as a jar, and it'll just use it. It's distributed, spins up to 1,000 node clusters, or I'm running it on my laptop. I'll show you what you can do. It is all WYSIWYG. It is all graphical. You just drop things in there, hit some settings, but it actually works. And it works, it's at every single Global 2000 company. It's been open source since 2014, and it's got massive adoption. I mean, it's the easiest thing. If you're a programmer and you have some sense, yeah, it's unbelievably easy. If you're not a programmer, it's still easy. You'll just maybe make the ugliest things you ever seen, that I call spaghetti flows, like spaghetti code. And, you know, things will work, but they'll work in a really crazy manner, or they'll just waste too much memory, or they'll find ways to make an infinite loop in something that's where you can literally see the loops. And I'll show you some of the cool features is you can see data live as it goes through the system and stop and start it without losing it. And change your code by just dragging a line somewhere and having the data live start going somewhere else. This is great for anything where you need to pick up some data, move it somewhere else, maybe validate it, encrypt it, zip it, change types, you know, enrich it, augment it, that sort of thing, and then drop it somewhere else. To me, this is my Swiss Army knife. If I don't want to write code yet, see if it will do it for me. If it does what I want and is fast enough, you know, you're ready to go. You run in production. I've got customers who run the same flow for 8-10 years in production. This scales down to in live, let's say brown trucks, up until largest government systems in the world, moving data around. It, you know, stays in its lane. It's not a messaging system. It's not a stream processor, but it does a lot of everything, and it does it pretty well at a very solid level. I know people who just download the open source tool and left it running for a couple of years, doesn't crash. Only thing you ever have to worry about is running at disk space. It can produce a lot of logs, and it'll store a lot of stuff on disk encrypted if you like it. Again, it came out of the NSA, so every level could be like 3 or 4 levels of encryption, which most people don't do that, but you can. Kind of cool. I'll show some examples of that. Sometime I go the wrong way. Okay, and this is the killer feature for anyone who's ever had to debug code or had to justify that your code is working or had to do any kind of auditing. Again, NSA, this makes sense when you hear that. Every step in your flow, and that's what we call a program, has an audit record. Every step. So like it comes into a flow, I read it from a cable, I get all the metadata, it goes into what we call a provenance or lineage record. And then each time it transforms or moves through your program, there's an audit record. And this tells you the time, size of the file, a unique ID for each step that you can step into, who touched it, how, there's a logged in user, what was the name of the component that was doing it, did it have a unique name, any kind of metadata that the system might have generated. So if it came out of an FTP file, of the FTP server, when I grabbed it, all that kind of stuff. And it makes it available live in the coding environment, but it also keeps it in a data store temporarily, it could be encrypted. And then on the other end, it eventually expires. But there's downstream systems you can automatically plug in to send it to. So if you want to store this auditing information forever, I can push it to the database, I can push it to Kafka, push it to wherever you want, just in a big file. Very easy. This is very helpful for auditing purposes, debugging, just seeing what's going on in the system. Very helpful to see what's going on when these things are running in, different clouds, different environments, hundreds of servers. Extremely helpful. Now, some people don't like running servers anymore. Some people, that's too much work. So there's a version of NiFi where you can take that flow you write and using the stateless engine will just run it idempotently, start, stop at the job it's done, and you can automatically deploy that to AWS Lambda, Azure functions, or whatever Google calls theirs without a problem, or with one of the engines that does functions as a service. If you want to just run something and have it be done, you can do that. By default, NiFi just keep running continuously forever, for all time. What's cool is if your data looks like, I didn't mention this, NiFi takes in any data, so it's an image, okay, if it's a zip file, sure, PDF, Word document, whatever, I don't care. But if your data looks like a table, if it has fields, it has names, it's JSON, maybe it's formatted text, maybe it's a log file, maybe it's a Parquet file, Avro, a syslog, something that's somewhat structured, well, then I can take it as if it was a record in a database and do live queries on it, convert it to other formats. This is great again for uplifting some legacy systems and pushing them in formats that people want for, the new cloud data lakes or Snowflake or any of those sort of things. Very easy to do, no code. Doesn't matter if the fields change. I can write one flow. I don't care what the data is. You tell me it's always going to be C, comma, separated values coming in. Boom, just load them in. It'll change it on the fly for me. You don't have to change any code. And connections to lots of funky stuff. And we've got built-in ones. So if it's one of the standard things people do, you can just grab it, change a couple parameters and press deploy. Really nice. I'm going to show some code, which I probably can't do with this little clicker guy. Oh, and for scalability, it sounds cool, but what about a lot of records? A couple of years ago, we did a couple of tests to see what we could push through. And 12 trillion events on 150 nodes in Google Cloud was not stressing. So, and this is again, the flow was pull something out of a cloud bucket, which was a zip, unzip it, look at the data, do some enrichment, transform it, then drop it to another system somewhere else. Again, pretty big throughput, and these are not, these massive systems. These are, I believe, we're running 64 gig RAM, which probably what you have on your iPhone now. And, a decent amount of disk, but, maybe a couple terabytes of disk. And that's all you need, maybe 16 core machine. Pretty cool, pretty fast. But let's show some stuff running. Oh, and if you're interested in some of this stuff and you don't want to have to worry about wiring it up, there's a free Docker Compose one out there that will spin up the whole environment for you, and you can run it, play around with it, and shut it down. Pretty cool way to do it. Let's see if I could see the screen here with all this fun stuff. Let's see if everything in the world has timed out, possibly. Okay, this is a live NiFi environment. This is what the code looks like. If you want to call it code, it's however you want to define it. This is a flow. What I have here is one that grabs all the weather data in the United States at once. There's a giant zip file that Noah puts on a directory. So what's cool with NiFi, I could just run it continuously, or I could just run once. Otherwise, I'm going to run out of space on my laptop. So I'll run it once, and this is gonna trigger, first step is grabbing that zip file. And then I'm gonna decompress that zip file, unpack all those files. Here, I'm gonna look at the metadata. And the files that come out of there are XML files that start with a K if it's an airport, which is the standard for airport naming. So if it's an airport one, those are the ones I want to look at. So I'll just grabbing just these, and in one step, I can read XML. You see here, there's nothing hard-coded saying what those fields are. So if no one tomorrow adds another field, takes them out, don't care. Can reuse this for anything else that's a zip file of XMLs. I convert it into JSON. This is a little SQL I run against that data based on the field names. And it's pretty straightforward here. There's a couple of unknown ones came out of here, so I just filter those out as JSON that comes out the other end. And you can pick different formats. So here it comes in, I give it a schema name. By default, there's like 100, however many records in that file. So I want to make it a little easier for me on my individual records and not 1,000 at a pop. Now, if I could deal with, you know, 1 million records in one, I'm going to deal with one. Makes it easier for me to distribute the data. Also, otherwise, the data comes through the system too fast to watch. 1,000 records takes, you know, one heartbeat. It's too fast to watch. Here, I'm going to take that data. I'm going to keep it in JSON, but I want to add a couple of fields to it. Because for some reason, the government doesn't put a unique ID or a timestamp on there. So I'll add my own. And again, don't want to have to write any code. Add that here. I'm just going to publish that to Kafka. Each time I'm doing a refresh, that was 14,000. This is where I'm at. I just sent that to Kafka. And once it's in Kafka, anybody in the world could start consuming that, which makes it nice if you're need to send that somewhere. So this was on my laptop. I can now send that data up into any cloud. And you can just start seeing the data show up here. This is a tool to monitor Kafka, so I can make sure that's now, right? Okay, so it showed up in my Kafka cluster. It'd be nice if that was in some cloud somewhere, but I didn't know the network here. So it's also running on my laptop. So that's a lot going on the laptop. So if it takes a couple of seconds to process things, you know, not the end of the world. So there's that key I mentioned. There's a built-in timestamp. With Kafka, it uses an offset to know how to get into that file. I mean, there's only certain ways you could store data. I mean, and here, this is just what the data looks like. It's JSON. Now it was XML. I just had to change. It picked the names based on the original names. Some of the names are not the best, but that's what the government gives you. You can see one of the fields tells you the original name of the file. I don't know if making it bigger makes it clear around there. Yeah. And those are the fields that the government gives you. Pretty good observation data. Most airports update every 15 minutes. So this is really slow data for me. That's why I grabbed the whole country. But yeah, some systems give you much faster data there. But again, I didn't have to write any code here. Now, at some point, someone's going to want to write some code to look at this, right? Do something with it, maybe put it on a dashboard, maybe use it within your app. Now we've got, I'll show you this other system. This is a system to run my Flink code. That is the darkest, most difficult to read thing ever. Sorry about that. Let's see, we change what. Oh, that's worse. How about Dracula? That's probably. You can tell this is for a corporate environment because we've got a Dracula mode. Oh, GitHub. Maybe GitHub is legible. That's a little better. So, yeah, I can see that. The SQL is pretty straightforward. Don't know if maximizing it. This is just an example to show you some of the SQL. We showed you some of the things you could do before, but where it gets interesting is NiFi got the thing with no code into a stream of data. The stream that's buffered for as long as you want that to be, how much you can afford. Most people keep like a week or two in stream. So I've got this data. I'll show you this one. This is Transcom. That's the tri-state area for New Jersey, New York, and I don't know if it's Pennsylvania or Connecticut. And it's all the road system updates. Every time there's an update, that's a little more frequent than weather. Well, this has lat long. Weather has lat long. So if I want to join, I could take Flink and join those two together by lat long, and maybe do some math around it. There's some equations. Give me an area, like give me a 5-mile radius around this lat long. What's the weather there? What's the transit there? Oh, also there's feeds for, Twitter just made that feed 20,000 now. That used to be free. Different feeds together, join them on something, loosely join them, supports unions, all those sort of fun things you could do with SQL, and you start aggregating live data as it comes in, and then pull in some data that you might have stored, because Flink can read from databases, you know, whether it's a regular relational one or a NoSQL one, pretty straightforward. Let's see where we go. Okay, that's the weather. Other common ones, I was mentioning that Transcom, it's Connecticut. So I'll start that running. I could start it or run it once. And that is just going to grab the RSS feed for that. Again, RSS seems to be a common thing for government notification kind of systems, which if you have to write that by hand is a pain. Again, take that XML and convert it to JSON. I can convert it to Avro or something else, but this is that provenance data I mentioned before. So as the data comes through the system, I can see everything about it. Again, if I wanted to use this metadata as data, I could send this to a stream in NiFi or somebody else and store it or do live coding on my metadata. And then that stream I could do live, and then you get the, you know, we get into a cycle of how many levels of processing of the metadata do you do? But it's interesting things like how many records, size, and we could look at the records as they come through just to get an idea what's going on here. And this one is, you know, a little hard to read, but this was giant XML file. This was what was going on at Yankee Stadium, caused some delays. So they give you back what's happened if it hasn't been resolved yet. Sometimes they don't resolve their data, which is why you might want to downstream change that. But that's just an example. And then we get, you know, that's pretty ugly format to look at. So downstream, I split it, do a query on here just to, if I needed to change it again, add some points, grab that lat long out of there, just so that, again, that's a good way to join, pseudo join data that's not really related. Split it up, spread the data out. I send it to Kafka, which feeds it over here. So when this is this still live? I think it's still live. It'll send that data when it comes downstream to Kafka, and then it'll be live in the system. So we got a couple thousand more came in. Pretty straightforward. If we want to look at it, we could take a look just to see, make sure the data came into the system. I've got 19 megs of it from today. We're pretty close. Got a couple. So this is 11:56 and 30 seconds. So pretty recent. Again, timestamp. I pulled out those individual lines from the XML. So it's a little, makes more sense and easier if I want to query it. And we added the timestamp, a unique ID on there so I can map that back to things. And I pulled out from one of their fields the lat long. So now I could put that on a map, join that with things nearby. So I could say, hey, definitely don't go this place on the road. Weather's bad and there's some traffic stuff happening. Pretty easy to do. Lots of different data you could do like that. REST endpoints are really easy. That's why I tend to do those. And it's something you can get, like the government has air quality readings. Same thing, don't really have to write any code unless it gets really weird. Like the GTFS protocol, really ugly. I try to do it in here, but that really needs some code. But if I needed some custom code in Java or Python, I could write it and I put it in a archive file, drop it into the cluster, and it'll show up, and I can just start using it, and it looks like anything else. So now it's distributed code there. I just pick it from the list. I've got the ones that I've written. You just drop them in, connect them, and now it's part of something that can be distributed to 1,000 node cluster. So most people can get by with 3 or 5 nodes worth of this. Will ingest gigabytes of data. It's only limited by network. It's space. Sometimes RAM. That's about it. We're almost at end. I don't know if people have questions or answers. I don't know if there was someone online. Can't tell. But I'll put these slides up. I'm guessing these will be recorded, and I have all the source code. The source code is pretty easy because it's these boxes. Fortunately, there's version control and things like that. Like for these, I just download it as a JSON file, and all your code is wrapped up in that JSON. Just import it, start running. You set your own parameters, values. These things proprietary. Other than that, pretty easy to do. Again, open source. Just requires a Java JVM version 8 or 11. Probably should have the biggest RAM available for it. 50 gig of space, probably good. It generates a lot of logs unless you turn them off. Thank you. Hopefully that actually did come through and that did work. If not, okay, very cool.
Awesome.
That's my. Thank you.
Thank you.
Yeah, he's a cute little